Pick up from where the last video left off, and with some of our modified input files, we're going to show how to submit jobs on a remote cluster using the SLURM batch job scheduling system. So first of all, if you're logged into a cluster, like I'm logged into the Freya cluster, you can type in man slurm, and actually this might not work on some systems. So for other systems, you'll have to go to the SLURM documentation website or whatnot. But this is really like the manual, and will tell you a lot of information about different commands that are used to monitor and kind of handle these jobs. So one useful command is the SQ command, which if you just type in, it will allows for a little bit of snooping. You can see everyone who's currently running jobs. So F Rizzuto is currently has a lot of jobs running or in queue, etc., etc. And so if you add in a -u, that allows you to filter. I mean, you could also do, I guess, a SQ pipe grep, and then I can just do grep for F Rizzuto, and it'll show all the lines and it highlights them. Or you can do SQ-U F Rizzuto, and it should do basically the same thing. And so that's fine, but if I want to check for my own jobs, I don't have anything in the queue right now, so that's good. And right, so in the previous video, we created all these input files using this modified input Python script that we developed. And then we created this density ratio 10 folder. Let's go ahead and check our modified input file. So 0, or actually how are we counting here? Yeah, from 0. 0, 1, 2, 3. So I think I got that right. I didn't copy it in though. Input 3 into DRAT 10. And then we need a SLURM submission script, which ideally I generate on the fly, but I don't know it that well. And once you get a template made, you'll probably just be tweaking the template rather than creating them from scratch. So I'm going to just kind of walk through this line by line. Okay, so this very first line, which is the shebang /bin/shell, is telling the system that the contents of this file can be treated as a shell script. So that's nice because then you can do just regular shell commands, like this date command, which will print out what the current date time is, so that will get outputted to standard out, and then with this SLURM system, that will get saved to a file, and you can then know when this started. So that's kind of nice. And then you can also do all this module stuff, which I'll go ahead and delete some of the extra lines. But so this is kind of these lines with the maybe module purge, module load, Intel compiler, module load, Intel MPI, module load, HDF5 MPI, is the same sort of stuff that I would do on a command line before I would run Athena, even if it wasn't in parallel. And then this is not, I think, too necessary. Okay, and so one thing that we haven't looked at, so we've seen /Athena-I input, or athinput.rt, etc. This -t is giving the wall time limit of 5 minutes. And the reason why doing this wall time limit of 5 minutes is then we can actually do some extra stuff at the end of the script, like echo done, to kind of show that we got to the end of the script as we were expecting to do. And then this -d is telling a directory to put the outputs. So when you run Athena in parallel, remember you get those ID0, ID1, ID2, where all the outputs of each processor are placed. And so that can kind of flood, that can kind of flood a given directory. This is nice and clean right now, just to input 3 SLURM and Athena. And so that reminds me, we're going to have to modifier Athena-I line, instead of saying input, we want to say input 3. And we're also going to need this out folder, otherwise it will probably crash. So we'll make dir out. And that could also be done, right here, make dir-p out. So make dir-p means just don't error if it already exists. And so this will make sure that it doesn't, crash for a dumb reason. Okay, and then so up here we have all these sbatch directives. So this sbatch-j is giving a name to the job. So this is kind of cosmetic, but it'll show up in the sq command over here. So if someone has test 3, test 4, etc., etc., we will have this kind of gibberish. So we're going to call this drat10. And then the name of the output file. So we already have an output directory, which is out. And so let's just go ahead and cap lock this to make it easier to, in typing, to be able to tab complete after only one character. And we'll just cap lock that as well. And then this mod j means to use the job ID. And so if in case we're running a lot of jobs in the same directory, which I try to just run one job per directory, but let's say that this crashes and we don't clean up these output files and then we just try doing it again, or we need to do a lot of restarts. In that case, you don't want to be overwriting these standard output files, standard error files, not necessarily. In that case, it's nice to have this unique identifier, which are these numbers, the job ID, which are assigned for every job that gets created. Okay, and then the number of nodes we're requesting, we'll just request 1 for this sort of tutorial video. Number of tasks per node, we'll do 40, which is fine. And then the amount of wall time we're requesting, we'll do 9 minutes. Where we're going to receive emails and what type of emails. So this can be like begin, end, etc. I just do all because I don't think it's ever too much. When you're running a ton of jobs, it is kind of a lot, but it's fine. All right, and then I guess I forgot to save that before. So now I'll save. And yeah, so that should be fine. So if we do sbatch SLURM, that submits this submits this job. And I think this kind of like saves the content. So even if I were to modify the SLURM script now, like for example, if I forgot to do make dir-p, or if I want to change this to out 2 and out 2, or if I would just want to change it to something else, and then if I were to save, I didn't tweak it, but even if I were to save, it won't notice that. And so let's go ahead and check on the status, and wow, it ran really quick, I guess. Usually this would be queued, but it ran really, really quick apparently. And so it started and then it's done. So there's definitely some sort of error. It shouldn't have gone that quick. Fatal error, 640, oh yeah. So in the input file, and I always forget about this. The input file, and I don't think that this is required because it's not in the ORSAG tang, but this is a different version of Flash than we were working out with the tutorials. This is a modified, or this isn't Flash either. This is a modified version of Athena. So it's this auto with nproc, you need to set it to how many processors you're using. So let's go ahead and let's do a little cleanup and remove the things that were, okay, that's fine. So we removed the things from the old job, which was unsuccessful. And we'll try this again. I guess because it's Saturday, maybe it's going to be really short queue times. Yeah, it's running already. So when it's, so this ST column stands for the job status. So that can be pending, PD, can be running, so this R status. It can also be like sleeping with the S status. So it's kind of the same thing if you do PSOX. It's not the same thing. They're different statuses, but there can be some like, I wonder if there are any zombie processes right now. T, I think, stands for terminated, so that might be kind of a bad thing to see that. So those shouldn't persist, at the very least. But I think it sometimes shows a Z for a zombie process. But, yeah, I don't see it right now. Okay, so it's still running. We can look at our output file. It's on cycle 9. Can do a tail-f out Athena, and that'll continuously show whenever this file gets modified until you Control C to kill it. And then the error file, no errors right now, so that's good. And the output file, so yeah, they created one directory for each processor, and it's output some initial files. And this cloud.hst, I don't think it's every time step, is it? So let's look for HST. So it's DT of 0.5, whereas this output file, we have a DT of like 0.05 roughly. So that's going to happen every 10 steps or so. They'll get a new value. And yeah, so that's kind of a little basic. So this was just for a test. We don't really need to keep running this. So let's say that we wanted to cancel this job. That can also happen, for example, if in your submission script, maybe you have your job still pending, and in the submission script, you realized, oh joy, I submitted this for only 10 minutes, and I actually want to run it for an hour or 7 hours, or etc. And you can't just change it by modifying the values after it's submitted. After it's submitted, it basically processes all this and saves it as the job ID. There's probably some database and has the contents. Maybe it's a dictionary under the hood. It's not in Python, but it might be kind of related. So you can do the scancel command, and then we'll just copy paste the job ID, and then you can do sq again to confirm that. Okay, so it's got a CG status, which means that's completing. So it definitely noticed the scancel command, but it's not done. Sometimes there can be, depends on the system that you're running on. Sometimes it can take a few minutes. Maybe that was more for PBS Torque like 5-6 years ago. Hopefully things are a bit better, but sometimes it can take a while. All right, so this one's already killed, which is nice. And so now if we look in our error file, it mentions job aborted. So that was part of what was going on during the cancel. So it's not like it really kills it immediately. It sends probably a sigterm command, and then it allows it to wrap up. It doesn't toss a sig kill command unless not by default, I guess. Okay, and so yeah, that's kind of the default, not the default, but a little bit about how to run and monitor jobs using SLURM on a remote cluster. Hope that helps, and goodbye.